Today's lesson is on the application of linear systems. And so they're all going to be story problems, and they're all going to be story problems involving substitution. So because in today's lesson we will be dealing with substitution, solving systems using substitution, we will be dealing with linear equations in the form y equals mx plus b. So let's remember, we have m, which represents slope, and the b, which represents y-intercept. But let's go back and think about what words do we want to look for in a story problem that we can correlate to slope and y-intercept. So in the story problems, we want to look for the words rate or each or every, and that will correspond to your slope, or m. And then you want to look for other things that, like your starting amount or what you already have, or if there's just like a one-time payment, versus your slope where you're going to pay maybe something multiple times. Your y-intercept would be a one-time payment. So just some things to look for to help you write your equations. Alright, so here's the first example. You have $22 in your bank account and you deposit $11.50 each week. So you already have $22, that's what you start with, and then you deposit or you add $11.50 each week. So you can stop right there after the first sentence and we can write our first equation. Y equals, let's see, the slope is $11.50, the rate of change, $11.50 each week, and then we start with $22. At the same time, your cousin has $218 and is withdrawing or taking out, subtracting $13 each week. So, to write an equation to represent your cousin, y equals, if you're taking $13 out, you're going to be have like a negative rate of change. So negative $13 each week. And then your cousin started with $218. Alright, and then the question at the end, when will your accounts have the same balance? So they're asking when, so that's referring to time, and since we're talking about weeks, we want to know how many weeks will it take for your two accounts to be the same. So for them to be the same, we're going to set the two equations equal to each other as if we're doing substitution. So to solve this, I can write an equation, 1150x plus 22 equals negative 13x plus 218. And I'm going to solve the system, solve the equation for x. So I need to add 13x to both sides. So if I combine like terms, 11.5x plus 13x, that would be 24.5x plus 22 equals 218. And now I need to subtract 22 on both sides. So 22 cancels out. 24.5x equals 196. Divide both sides by 24.5. And you should get that x equals 8. And what that represents is 8 weeks. So it would take 8 weeks for those two accounts, go back up to the beginning, to have the same balance. And we actually don't even need to solve for y because they're only asking when, they're not asking what the balance is. So we're only solving for how many weeks does it take, and it takes 8 weeks. Alright, next example. Suppose you are starting an office cleaning service. You have spent $315 on equipment. And then to clean an office, you use $4 worth of supplies. So that right there is talking about how much money you have to spend of your own. So you spend $315 once, and then you're going to spend $4 every time that you clean an office. And then it says you charge $25 per office. So that's how much money you're making. It says how many offices must you clean to break even? So what does it mean to break even? It's basically saying if you look at all the money, if you add up all the money that you spend, and when it is equal to all of the money that you make. So we're going to write two different equations, one that represents all the money that you spend, and then a second equation, all the money that you make. So the money that you spend, y equals, you have to spend $4 per office that you clean. So $4 per office, plus you had to spend that original $315. And then we need to write an equation for how much money you make. And you're charging $25 per office. So y equals $25 per office, 25x. So there are the two equations. And to find out when will you break even, we want to know when will the amount of money that you spend be equal to the amount of money that you make. So to solve these by substitution, we can set it up as 4x plus 315 equals 25x. So to solve this, we have to get the variable x on one side of that equal sign. So I need to subtract 4x on both sides. So 315 equals 21x, and then you're going to divide both sides by 21. Divide by 21. And you should get that x equals 15. So what did we just solve for? If it was $25 per office visit and $4 per office visit, x represents the number of times that you are cleaning an office. So for you to break even, you would have to clean 15 offices, and after 15 you'll start making a profit. So let's go back up. That is the only question they're asking. How many offices must you clean to break even? So we don't need to solve for the other variable. We can stop at solving for x. Alright, last example. Suppose a model airplane club publishes a newsletter. Expenses are 90 cents per copy for printing and mailing, plus a total of $600 for research and writing. The price of each newsletter sells for $1.50 per copy. How many copies must they sell to break even? So another break even question. So break even is once again where you're looking at an equation that represents how much money you spend, and we're setting it equal to how much money you make. So this newsletter, they have to spend $600 plus 90 cents per copy. So 90 cents per copy plus $600. And then how much money are they making? They're selling them for $1.50 each per newsletter. So those are our two equations, how much money you spend and how much money you're going to make with the newsletter. So we're going to solve this by substitution, and we're going to plug this equation into the bottom equation. So 0.9x plus 600 is equal to 1.5x. And at this point, I want you to pause the video and see if you can finish solving this, and then come back and check your answer. So you should have solved and gotten that x equals 1,000. which means this club would have to sell 1,000 newsletters in order to break even. So there is your full lesson on applying the idea of substitution, solving systems using substitution, to real-world scenarios. Good luck!